Thanks, Claire. Hi, everyone. I'm based in Hobart, Nipaluna, and that's the land of the Muwinina people. We're all joining these calls because we're interested in decision making, and we either make decisions about the future based on our historical experience or about information we can learn about the future. And ultimately, good decision making depends on forecasts. In our case, we're talking about environmental forecasts through these series of briefings. We last met on the 25th of August. The previous one before that was June, and the motivation for us in getting together is to understand how we'll be challenged this summer by the long-term trends in climate change as well as different extreme events. Feedback from that second briefing, which is available on YouTube, was that looking at the forecast performance was really valuable to people. What did we tell you at the last meeting, and what has happened by this meeting? Obviously, we do a lot of testing of our forecast using historical data, but that real-time testing seems to be really appreciated by people. And the other one was to spend a bit more time today at the end about help with where you should be in a planning or response phase to heat waves. On the right-hand side, just showed the current picture of where heat waves were at the moment. And as we predicted in June, we are entering marine heat waves now on the east coast of Australia. And the impacts that we've predicted from previous work are likely to be generally negative in southern Australia. The graph on the left-hand side lists a bunch of taxa. If you're to the left-hand side of the dotted line with a coloured dot, that means things are going to be worse for those species. For habitat-forming life like seagrass and kelps and corals, again, the more things like heat waves, number of days, duration, temperatures tend to lead to negative effects. The final picture on the right reminds you that depending on where you are in the animal's range, the effects will vary. So if your heat wave strikes you at a location where animals are living at the warm edge, we expect those to be less detrimental. We expect those to be more detrimental than for species living in the cooler part of their range that then warms up. We use multiple lines of evidence when we forecast the future. In previous briefings, we've tended to focus on number 3, which is just using the dynamical models. But today we'll also give you a look at an analog forecast. And I think that's very similar to what your experience is as operators around Australia. Based on what you've seen in the past, if it's an El Nino this year, well, what would you expect based on your experience of previous El Ninos? So that's the analog model of forecasting, and it's what I hope you'll also continue to use in the future at the same time as you take information from dynamical models. As many of you know, we're also using statistical models for doing forecasting, and machine learning is one of those options, but we won't cover that today. And I'll pass to Claire, who will press the unmute button.
Yes, that would help. Thanks, Alistair. All right, so I'm going to take us through the current ocean conditions that over the last couple of months since we've last caught up, and that will lead into the forecast as well. So these are the current conditions for sea surface temperatures around Australia for November. So on the left-hand side, you can see this November in context of all the past Novembers back to 1900. And you can see that we're not the warmest. You can see the mouse here. It's not the warmest November we've had, but it's up there in the top sort of 8 or 9 warm Novembers. So the reason we're looking at what last month was is to have an idea of how much heat is already in the system as we go into what's looking like a warm summer. On the right-hand side, this gives you a bit more of a regional or a spatial picture. So this sort of yellowy colour here is the top 20% of temperatures at the surface in the last 120 so years. So for a lot of the East Coast, we've been in that top 20% of temperatures. For Southern Australia and also parts of the Southwest Coast, it's been very much above average, so in the top 10%. So it's pretty warm already. This is at the surface. And across small part of the GBR, Northern GBR and the Gulf and parts of Northern Australia, it's been pretty average. But we'll see as we go through the forecast how that's likely to change. This is the big picture. I think it's always good to get the context of what's going on in the global ocean so you can look at how that's driving what's happening in Australia. So we've all been talking about the El Nino event that's currently underway. That's what you can see out here in the Pacific Ocean. This warm signal here is a classic El Nino signal. If we look around Australia, we've also got a positive IOD, so Indian Ocean Dipole. You can see it here. Basically, it means it's cool on this side of the Indian Ocean, warm on that side. And the combination of those two big drivers is what's driving the Australian climate and the temperatures around Australia. It's also been warm down the east coast of Australia, off Tassie, that's a recurring story, and out into the Tasman Sea. Anywhere that's, so I should have said, anywhere that's pale pink or pink is warmer than what we would normally expect for this time of year. So this information is from the last week. We then go to look at marine heat waves. So this is a satellite product. So it's from the 4th of December, so a few days ago. This is where we've taken those temperatures we've just saw in that previous slide, and we slice them out and look at the top 10%. So your top 10% of historical temperatures that have been experienced in those locations, and anywhere that's coloured yellow through to red is showing marine heat wave conditions for this time of year. So Tassie is still lighting up down here, and sort of southern New South Wales, maybe parts of Victoria and eastern Tasmania. That's what we saw in the August briefing as well. So that heating has continued. There's also some marine heat wave conditions being flagged on southwest WA coast, very close inshore, but that's only developed in the recent few days even. And this was, so we gave a briefing, I gave a briefing a couple of weeks ago to the Great Barrier Reef Marine Park Authority and other operators that work on the Great Barrier Reef. And feedback from that was people were also interested in the subsurface. So Alistair and I would also be interested if this group are interested in that. So the plots that you've just seen showing warming is all at the surface. So it ranges depending on what we're looking at from a few centimetres to the top 1 metre. However, we know the corals and fish don't necessarily live in the top 1 metre. So this gives a bit of an idea of recent conditions down to 300 metres. So it's average sort of heat content of the top 300 metres. Now, this product doesn't go onto the shelf. So that's why the shelf is basically white. So if you know your bathymetry, you can see, you know, roughly where the edge of the shelf is. But the point of showing this plot is there is a fair bit of heat off the shelf. So particularly up in the northern GBR and down off New South Wales and eastern Tasmania. So even though we may see some cooling at the surface in the forecast and also current conditions, there's still quite a bit of heat underneath. So it's worth bearing that in mind. So how did our last forecast go? So we spoke, I think our last briefing was the 25th of August, and so we were showing forecast for September, October, November. So there's a lot going on here, but basically the top row is what the forecasts were. They're the ones I walked you through in the last briefing. Underneath is what we saw. So if we start with September, here on the left, this is the forecast at the top, and you can see we were predicting heating over the GBR down the east coast and that persistent heat off eastern Tassie. And that's pretty much what we saw in September. There was some heating also forecast on the northwest shelf. We didn't quite get the magnitude of that, but did indicate it was going to be warmer than normal. Step through to October. Similar story down the east coast and Tassie, that heat is fairly well captured, and northwest shelf. Again, warmer than normal, but we didn't quite get the magnitude. And it was also a bit cooler in October and November on the GBR. And so that's just at the surface. There was a lot of wind activity that the model didn't capture. Forecast for November. So bearing in mind, we are now forecasting from the end of August through to the end of November. So the longer we're trying to forecast, the less skill there is in the model. So again, the model does a pretty good job. It picks up that persistent heat off New South Wales, Tasmania and Victoria. And you can also see that northwest shelf signal and off the offshore reefs off there as well. Over-predicted GBR and parts of northern Australia, which were actually cool or around normal. If we then take that information and look at the top 10%, again, for marine heat wave, we've got the trial forecast, so these aren't publicly available yet. We've got September, October, November. and what we saw underneath in the bottom row. So when we're looking at those extremes, and they are harder to predict than just average conditions, the model did a pretty good job. We picked up marine heatwave conditions off Tassie, parts of the GBR. We didn't get that northwest shelf heating for September or October, though we did predict it was warmer than normal. Same story for October. East Coast and Tassie did a pretty good job, and same with November. You can still see the same areas lighting up in the model that were lighting up in observations. So it's a really good way to get some feedback on, what did the forecast say, and what we actually saw. All right, I'm going to pass over to Alistair now to take us through the main climate drivers.
So by about June this year, we knew that an INSO was likely to be declared, and so that gave us some signal about the conditions we expected. And so this is again one way of using information about climate drivers to tell you about the future. And they suggested that we would see some warming around southeast Tasmania. Thank you. With this one here, we're just going to look at the signals then of El Nino, which comes from the Nino 3.4 region box, and then also the Indian Ocean dipole, which comes from the balance of temperatures found within each of these two regions that Claire pointed out on one of the earlier slides. And these are then the signals about what's the pattern of the large climate drivers that will influence our area. The first one, El Nino. It has been declared by the Bureau. It continues to drive patterns around the Pacific. We're currently in November, according to this forecast, early December, which is the white dot on the left-hand plot. And the model is suggesting that for the next few months, we're going to be even seeing stronger El Nino conditions, and they're going to peak in about January, and then El Nino will start to deteriorate over that period of time. This is called a spaghetti plot, and those different lines of spaghetti show that the model has 99 realizations, and they will tell us how much variability there is. You can tell by May, all of those 99 members are still in the light pink colour, which suggests that El Nino will still be present, but it is starting to weaken. The Bureau is not the only people making one of these forecasts. Different places around the world make similar forecasts of El Nino persistence through time. And so the series of plots on the right-hand side show for each bar a different organisation's El Nino prediction. So for December is in the top panel, January is in the middle panel, and February is in the lower right-hand panel. And each one of the bars for each organisation is clearly in the El Nino zone. So there's no disagreement that through to February, all agencies around the world, their models predict that an El Nino will continue. With the Indian Ocean dipole, the prediction is that that's going to weaken, and we don't typically see an Indian Ocean dipole maintain its character past Christmas. In this case, we're seeing it deteriorate by January, and by February, it's back to neutral. And again, the spaghetti plots show that in general, it looks like it'll be neutral, but some of those model realizations say there's a chance that we'll still have a positive IOD. The same series of plots on the right-hand side for different agencies around the world show that for December and January, there's generally good agreement that we'll be in a positive IOD phase. But you can see by February, one agency's model suggests that there will still be a positive phase. All of the 5 other ones suggest that we'll be back to neutral. So that forecast as we get further out is less reliable about what the sea surface temperature pattern in the Indian Ocean will be. You'll see why that plays out in the next slide, where we could look at what do we typically see around Australia using an analog forecast approach when we have different phases of El Nino, which are in the rows, and the Indian Ocean dipole, which are in the columns. At the moment, we're in the lower right-hand corner with one more click. That is the case where we've got a positive, an El Nino event, and the Indian Ocean dipole is also positive. That's what we could see from those previous 2 plots. So here on the right-hand side is for all of the years in which we've seen that combination, it's the water temperature pattern here, which shows that warming of Tasmanian waters. If we look into the future, by January, we still expect both of those drivers to be positive. And so this is the typical pattern you would see in January. Stronger warming off the Great Barrier Reef region, a little bit off the northwest coast and into Tasmania. But look at the right-hand side of this plot. We've only seen this combination in 1 year. So it's an average of 1 year. If you'd come back to the neutral box, there are about 5 or 6 years that we've seen that kind of combination. Let's shoot forward to February. We'll be either in the neutral or the positive phase, according to those driver predictions. And those are the two kind of patterns that we could see there. One more time as we go through to March. Again, if we're back in the neutral phase, that's what your historical experience would suggest that we're likely to see in March if we have a neutral Indian Ocean and we still have El Nino conditions. So you can gather this kind of data, use your experience to look at what have we seen in past conditions and what does that look like. But that requires that we have no climate change if these patterns are to continue, because we expect the El Nino today to look just like an El Nino 20 years ago. And we know that not to be true.
Thanks, Alistair. So following on from ENSO and the IOD outlooks, the next step is to look at the tropical cyclone outlook. So these are only released on the 1st of November, which is why we weren't presenting them in the last briefing. So for those operating in the northern part of the country, this will be something you'll need to take into account. So what I wanted to say here was typically El Nino increases the chance of fewer tropical cyclones. So when we look back in previous El Nino years, on average, there have been fewer tropical cyclones and tropical lows. Also, when we've looked historically, the first tropical cyclone to make landfall is typically later in the season. So it'll be around the second week of January. So you can see here on the right, and these, the links here, this is all publicly available, gives an indication for each of the regions across Australia the likelihood of tropical cyclones over the season, which runs to the end of April. I just wanted to make the point too, and which is an important one. So the models that we are presenting the sea surface temperatures from, the ones we've used in the last couple of briefings, ACCESS, it can't predict actual tropical cyclones. They're synoptic systems. These kind of models, when you're trying to look a month or 2 or 6 ahead, can't predict cyclones on where they're going to go. It provides information around the likelihood of cyclones. So our model is an ocean model, which has an atmosphere model, and they're both coupled, so they talk to each other. And we kick that model off with our best information around current conditions. But when it comes to specific cyclone events, that is not captured in the model. What is captured, so if you've got a, say, for example, warm conditions in a particular region in Northern Australia, you get a cyclone coming over it, you got a lot of cloud, you got a lot of rain and a lot of wind, and that will cause cooling in your, or in the water column where you are. And the amount of cooling depends on the strength of the event and how long it hangs around for. So you will see that cooling comes into the model in those initial conditions. So when we take that picture of the current ocean temperatures and we kick the model off from that, it'll have that information from that cooling that's happened due to the cyclone, but it won't have the actual cyclone in it. So it's important to remember that as you look over the forecasts this coming summer. And on that note, I know there's probably some concern around tropical cyclone Jasper at the moment. It's brewing off the sea off the coast of Queensland. So as I said, and as Alistair said, an analog forecast, what has happened in the past is not a guarantee of what's going to happen this summer. So, sorry, my lights are flickering because it's super windy outside. So we have got a forecast. We have got a cyclone that is brewing early in the season, whereas in the past, typically it was later in the season. This map here shows that there's no marine heat wave in the area at the moment, and so a warm ocean provides energy to cyclones, so that is a good thing. And there's also information. So if you're concerned, the Tropical Cyclone Warning Centre at the Bureau is the place to go for up-to-date information. But this is just an example saying to show that the typical conditions we've expected in the past are not necessarily what we're going to get this summer. Okay, so stepping through to atmospheric conditions. So these are terrestrial, but given that a lot of people operate right in the coastal zone or run estuarine fisheries, it's important to know what's going on. So overland. So typically an El Nino increases the chance of drier than average conditions across northeast Australia. So that means sunny, cloud-free days and low rainfall going into your river systems. So you can see here, this is for December through to February. So it's the same model that's giving us the ocean forecast. Most of WA and across Northern Australia, there's a very low chance it's going to be above median rainfall. If we look at the extremes, so the odds of it being super low, so in the bottom 20% of rainfall, you would normally get this time of year, there's a 1.5 to 2 chance, maybe 2.5 times chance of it being pretty dry in that bottom 20% across most of Australia. Particular of note here is southwest WA. It's looking really dry, so that's up around 3.5. That's also the combination of a positive Indian Ocean dipole that makes that exacerbates the impact of El Nino on rainfall for Australia. Coupled with that is our air temperature outlook. So on the left is just showing the chance of being above medium day air temperatures. The nighttime temperatures tell a pretty similar story, but a very high chance of it being a warmer than normal summer. So December through to February for most of the country. If we break it down into that top 20% of temperatures, so where's it going to be really warm or much warmer than usual? You can see WA, we're up to 4 times likely to have temperatures in that top 20%, most of WA actually, and also across Northern Australia. And you're going to see that reflected in the ocean temperatures that I'll present in the next few slides. It's getting pretty warm across the top of Northern Australia. Okay, so the way I've split these up, so because we're already in December, these are the next 2 fortnights. So the first half of December basically on the left, second half on the right going through to the end of December. Anywhere that's yellow is around 0.5 degree warmer than normal. Once you start getting into red, you're around 1.5, 2 degrees warmer than what you'd normally expect for this time of year. Anywhere purple, we're up around 2, 2.5 or greater. So looking at the next month or so, you can see, again, the same story for the East Coast. So New South Wales, Southern Queensland, Victoria and around Tassie, we're looking at anomalies, so how much warmer than normal, up to 2, 2.5 degrees or more for the next month. There's also a bit of heat starting to develop in Northern Australia, so off the Kimberleys and northern part of Northern Territory. And there's some heat here down the WA southwest coast. And we saw that in the marine heatwave tracker very close inshore. There was areas starting to show up as marine heatwave conditions. I just remember that somebody did ask me about Herd and McDonald Island in our last briefing, so apologies I haven't included them here, but the Southern Ocean is a lot warmer than it was at our last briefing. Coupled with that is always to think about the model skill. So this is provided along with the forecasts on our public-facing webpage, and it's what the main aim of this is anywhere that's green, the model does a good job at that spot at this time of year. Anywhere that's white, historically, the model does not do a good job. And that could be for a variety of reasons. It could be that the area is dominated by weather systems, which these kind of models can't capture. It could be very eddy rich, so lots of eddies moving around and not on the timescales that these models do a good job of. But you can see for the next 2 fortnights, the model does a pretty good job inshore. With the exception of parts of the New South Wales coast, because we've got a lot of eddies there. However, the caveat is when there's a really big climate driver, like an El Nino event, the model typically does better. So these maps are the average of the last 40 years of forecasts. All right, lost my mouse where it comes back. All right, now stepping through to summer. So bearing in mind the further out we're forecasting, the less certainty there is in the forecast. So for January and February, same story, continuing the same story of New South Wales, Victoria and Eastern Tasmania, still really warm conditions, much warmer than usual for this time of year. The difference here is what we're seeing as we go through into summer is that we're starting to see the Gulf and Northern Australia, Northern WA start to heat up. Offshore as well with Rolly Shoals and Ashmore Reefs. And Scott Reef, we've got temperatures up around 1.5, 2 degrees warmer than normal. There's also some heat off the Capes here in WA as well. So, and also the GBR. So the GBR is warming up. It's around probably 1 degree warmer going through January and February. So there's a fair bit of heat in the system. This again is that top meter of the water column. But as you saw from the current conditions, there is heat in the in the subsurface as well. Checking our model skill, you can see this time of year is pretty tricky to forecast in a lot of areas. We've got tropical cyclones, the monsoon is really active, and there's a lot of synoptic systems as well as eddy action. So these areas with white here, the model typically hasn't done a great job of those over the last 40 years. And so if that's your area, our advice would be keep an eye on the forecast. At the moment, they're saying they're warm. There's evidence to suggest that's a pretty good forecast, but you want to keep an eye on it because that will change. This model is run every day, so the forecast will update multiple times a week. Keep an eye on it closer you get to that period of time. Okay, last couple of slides on these. So we presented these last time. So these are the trial marine heatwave products. So what we're showing here is same setup again, next 2 fortnights, January and February. So we run the model, as Alistair said, 99 times every day. And that way we can use it to work out the probability of events actually happening. So we take those model runs and we count how many fall in that top 10% to give an idea of the likelihood of a marine heatwave happening. As you can see for the next fortnight, these line up with what the SSTs are telling us, that you can see the likelihoods are starting to increase in the northern part of the country, whereas down around Tassie, all the model forecasts are saying marine heatwave conditions, and that's what we're going to see in the category forecast on the next slide. So we step through to January and February, we're starting to see 60–70% of the model forecasts are indicating marine heatwave conditions from January and February. So bearing in mind that when we're talking about the top 10%, it is for that month. So if March is your critical time, that's when marine heatwave conditions are going to be important, particularly in summer because the system is already warm, or already the warmest time of the year for most places. So then it's a marine heatwave on top of that. So it's just keep it in mind. It depends on the time of year that we're talking about. If we take that information and look at what category the model is indicating, you can see that the next 2 fortnights, Tassie marine heatwave conditions are set to continue, and the model is indicating strong marine heatwave conditions. There's also growing marine heatwave conditions in Northern Australia. January and February, the heatwave conditions of Tassie have started to back off. However, still indicating the actual temperatures themselves are really warm, but they're not tipping that threshold. So there's still heat in the system. It's just not hitting those high thresholds for a marine heatwave. So particularly down in Tassie, you want to keep an eye on the forecast going through to summer. However, widespread marine heatwave conditions across Northern Australia and parts of the Coral Sea and the Gulf. So for those folks operating up there, even though the model skill is low, I think you need to keep an eye on the forecasts and potentially factor that into your operations over the next couple of months. All right, and on that note, over to Alistair.
Okay, so we've talked before about how forecasting can give you an increased preparation window. And we hope that since June, when we began the briefings, people around the country have been using this period of time before intense events begin to prepare and make sure that they're not in a reaction window. There are a number of steps that we've previously suggested that you take when you are not yet experiencing a heat wave, and all the way through to when you are experiencing a heat wave. And so we'll just step through some of those in a bit more detail to finish up the presentation today. For Southeast Australia, in June at the first briefing, we were predicting events, and so that you should have been assessing the risk. That was step one. By the second briefing, we had made clear forecasts that we would see heat waves in Southeast Australia, and I think that was the time to begin to plan your responses. For Southeast Australia operators, we're now in these events. So you're actually in a responding phase, and there are a number of things that I'll get to, I think, ought to be going on now because the events are occurring. In Northern Australia, however, you're at the point of time where we're just forecasting what might be happening in your area. So you're a step behind. And so I hope that there'll be good collaboration between actors in Southern Australia and Northern Australia to share what you've done in preparing so far, because Northern Australia can look at what's been happening in states like Tasmania and New South Wales with the preparation actions they've been taking. It's a great thing of being in a big country. You can follow somebody else. Stage one was assessing the risk. Nobody's there this year. We've all moved beyond a prediction that maybe there'll be a hot summer. It's very clear that there are. But we do know of the things that you should have been doing at stage 1. My ticks down the right-hand side there suggest that at least 4 of the 5 actions that should have been done did occur this summer. The bottom one there about identifying vulnerable human populations and which particular industries, I think was probably underdone, and we ought to do a better job of that in future. So where are we at in Northern Australia? An event's been forecast, use your preparation window. And I know these kind of things happened in Southern Australia. There was lots of consensus building and discussion with different groups. There was formulation of response plans. There was prioritisation and mapping. Early warning systems were put in place with monitoring implemented. Definitely there's been information briefings for a whole range of decision makers. The last 3 things, I don't have a good sense on how much those have happened because they're below the level of the national briefings. But there should have been perhaps efforts to reduce other pressures, increasing emergency funding, and even training people to respond to extreme events. If it's happening now, and this is where South East Australia, New South Wales, Victoria and Tasmania find themselves, I hope as researchers are looking to capture data so that we have better information for next time. There might be activities around restoration and conservation activities that would be occurring that mean that you're going to start thinking very seriously about what you do in a restoration activity, how this might influence on protected species in the southeast. There are a range of other things that I don't know how much is going on yet, and if you've got responsibility for planning, I hope you think about where you are in stage 3 at the moment. So there has been great sharing of information. Claire and I and Jamie are aware of a range of things going on around the country that propagate down from what these national briefings are. We know there are a range of state briefings and updates led by people on this call and other colleagues that are seeking to provide even more detailed information at state levels. Below that, in the seafood sector, there are also sectoral responses, and they might be fisheries by fisheries, which the Australian Fisheries Management Authority is doing, industry-specific preparation for, say, aquaculture or working groups for abalone. And all of that's led to action plans, government preparation and a range of media that's really, I think, also boosted the political awareness around our need for responsive management in the ocean. We have a pretty good look at the seafood, but there's also efforts around biodiversity management in general. And so at a sectoral level, there have been briefings and discussions with the Great Barrier Reef Marine Park Authority and also with Western Australia. Increasingly, I know a couple of conservation agencies, the federal and state ones, are looking at what might need to be responses for vulnerable species. And the research community is also doing things like deploying equipment in a way that we can make better measurements of these ocean events. So it's been a great effort by our community over the summer. So for extreme events, I really hope that the forecasting has helped you to use the preparation window prior to marine heat waves. If you're in an area which doesn't receive a marine heat wave this year, I'm sorry for you, but I hope that you can also use it as preparation for long-term planning. And this is what our future is going to be like for the coming decades. We're going to have both pulse events like heat waves, like cyclones, like intense upwelling events, that we have to take into a consideration on shorter timescales, but not forget about long-term planning. And so things like fisheries adaptation plans that I know many jurisdictions are doing have to be done in parallel with the short-term responses. Thank you from Claire and I, and we'd be happy to take any questions after we cease the recording.